Is this big enough? Yes, no. Does that seem big enough? All right, so today we're going to be showing you guys how we can move away from writing raw SQL and using an ORM called SQL Alchemy. So first, I'm in my virtual environment, so make sure you're in that. Oh, make this bigger. All right, and like from last lecture, I have my app.py and my db.py, along with my requirements and then my database, my to-do database. So basically first we're going to go into our db.py and then basically just delete everything since we're not going to be writing any more SQL, and this will make our lives a lot easier. So first we want to import our SQL Alchemy object, so we can just do from Flask SQL Alchemy import SQL Alchemy and then instantiate a DB object using the SQL Alchemy class. All right, so now we want to model like what a task was. So previously we would create like a new task table and then have to write all these functions for it, but in SQL Alchemy to represent a table, we can basically create a class. So we can call this class task, and this will extend SQL Alchemy's like model. And then basically to tell SQL Alchemy what we want to call the table, we can just do this __ table name. My N key is not working. Oh, there it is. My N key is not working, I'm sorry. This is unfortunate. Let me just copy an N from somewhere else. All right. There we go. All right. And then we can do, and we say we just want to call this task like before. All right, so now basically to list all our fields, there are basically properties in our class or fields. So first we want an ID, and we can tell SQL Alchemy that this is going to be a column. And then to specify the type, we tell SQL Alchemy that's going to be an integer. So SQL Alchemy supports a bunch of types, so that's why we do db.integer. And we want to tell it that it's a primary key. So we just do primary key, true. Yeah. So now we want to move on to our next field. So we also have description and done. So we can do very similar things for description and done. So we can do db.column again. But this time it's a string, so very similarly, we just do db.string. And then we never want this field to be null, so we can say nullable is equal to false. And then same thing with the done field. So before we had like a done field to basically specify whether a task was done or not. So again, we can say it's a column, and this has type Boolean. And then we don't want this to be null again, so we can do nullable is equal to false. Does anyone have any questions so far of what we've done? Yeah.
How do you get it to autocomplete? It's not working for me.
Do you have Python, like the Python VS Code package installed?
Yes. If not, it's fine.
Yeah, I'm not too sure, but
Can you make it a little bigger?
yeah. Oh, no. Okay. There we go. All right, so we need to create like a constructor. So basically like how people can make their own task objects. So we can specify a function called init. And this takes in self, and then something called quargs. Do you want to explain this?
Sure.
Should I type this first?
Yeah.
Yeah, so basically in our constructor, when someone wants to make a task, they can specify what they want the description to be and what they want the done value to be. So we can say self.description, and then basically we do something called, we do quargs, which Young will explain, .get, and we can say description.
Oh yeah, so basically quarks is really cool like Python syntax, I guess. It's really nice because it lets you pass in any number of named arguments. So like, wait, I'm just gonna hijack your keyboard. Okay, so it would let us call like a function A with like A equals, or a function called F, and then it would let us have like some values. And then these get passed in as a dictionary into quarks. And then, so the quarks.get syntax, this is because it's expecting a dictionary. And then this lets us just check whether the description key is in that dictionary. And if it's not, it returns none. Does anyone have any questions about that? So it lets us pass in like any number of named arguments after the arguments here. So here the only argument is self, which is just implicit in any Python class. So we can just do something like that if that was the init, basically. Yeah, so let's say you just called like the init to task without anything, then the dictionary quarks would be empty, and then when you do quarks.get, like it returns none, yeah. So like the .get syntax checks whether the key exists in the dictionary, and if it does, it returns a value. If it doesn't, then it returns none, yeah.
Yeah, so we don't, so if description, like Young said, isn't supplied, then quarks.get description will result to none, but we don't want the description to be none because we made it non-nullable, so we can specify a default value in case it's none. So there's an optional second argument in using get, and we can basically say if a description isn't supplied, just default to like the empty string. So basically that's saying like, yeah, if they don't give us a description, just use the empty string by default. So same thing, so we're gonna do done. So if they specify done, we'll do the quarks.get done. And then if they don't supply it, we'll just automatically make it false. All right, so now we have this class task, but we need some way to return it to the client in a readable way. So basically we made a new task object. We couldn't just return this to the client because they wouldn't know what it is because it's like this Python class. So what we can do is we can make a function called Serialize that basically returns the dictionary representation of this task because like in app.py, in our, like we usually return like a dictionary. We do like json.dumps and then some type of dictionary. So basically we can just return a dictionary with the ID. So we can just use self.id, the description, self.description, and then done. Self.done. All right. So basically that's pretty much it for our task model. Does anyone have any questions so far?
Okay, sorry to interrupt. So the last thing regarding like the quark syntax, so it still might not make sense why this is useful at all. It gets really useful, like let's say task had 30 different fields, and then you wanted to set all those defaults, right? So you might have like self, comma, description equals the empty string, comma, done equals false, etc. And then you had like 30 of those. You can just simplify it by just having this one argument. So that's like the big benefit to using this shorthand.
All right, so we're gonna go into our app.py file, and let's comment out all of our routes except for get task. So we'll just start with that one. And then in the beginning of this file, we need to edit some things. So basically, we want to import our DB object and our task class. So we can do from the DB file, import DB and task. And then one thing we want to do is specify what we want to call our DB file. So we're just going to keep this as todo.db for now. All right. And then on Piazza, I posted some code. So if you go to the top, it's the first post, and then it basically just copied this code block at some configurations that I didn't want to waste time typing out. So, and I'll explain what this means. So we're just going to copy this right here before all of our routes and then save that. Okay, so basically, this configures our Flask app. So this first line basically tells SQL Alchemy that we are using SQLite, and this is the SQLite file to refer to when creating our task and querying them. In this case, this is just a way of basically putting this todo.db string in here. And then these are some other modifications. So these are just some debugging options, so you don't really need to worry about this. And then how we tell SQL Alchemy that this is our Flask app, we just do this db.init app and then this db.createAll statement. So reminder that db refers to the SQL Alchemy object. So this createAll is basically just an initialization of creating all of the models that we specified. So in this case, it would just create a task table. Okay, so we're gonna go over how to do get task. So it's pretty straightforward. So to get task, we can first create a task object, and then we can reference our task class by doing task, and then we say we want to query, and basically say we want all of our tasks. So we can do that. And what that will do is it will basically give us a list of task objects. And then to return this to the user, so if you remember, this will return us a list of these objects of this type, but this isn't readable to the client. So basically we need to call serialize on all of these tasks in this list. So basically we can do this neat syntax where we do task.serialize for task in, oh, I need to copy my n again, in task. And basically this is just kind of like a fancy for loop that basically iterates through our task list and basically replaces it with the serialized version of it. Does that make sense? Does anyone have any questions so far?
Oh, does anyone have any idea what would happen if you just did data and then tasks? Does anyone know what that would look like? So let's say we just replace this list syntax with tasks. Does anyone have any ideas? Okay, so like Megan said, the reason why we can't do that is it's like if you try to print an object in Java and then you got that memory reference at some memory address, it ends up being something like that. It's just how, so if you go back to db.py, these objects are just stored as memory references in Python, and then so we have to call serialize to get it in a normal format, basically. Yeah.
All right, so before we run it, we have some new dependencies. So first we want to pip3 install SQL Alchemy. All right, and then we also need to pip install flask underscore SQL Alchemy.
Oh, yeah, and the reason why we need both is SQL Alchemy is an ORM, but then Flask is just one of many different web servers for Python. So we need to install the connector between those.
All right, so we updated our dependencies, but as you see, so as a quick refresher, so we have this requirements.txt file, right? And if we basically read it, we can see these are the dependencies that are installed every time you do pip3 install -r requirements.txt. But we just installed 2 new dependencies, but the requirements.txt didn't update. So we actually have to do this manually. So at any time, you can always do pip3 freeze, and basically this will give you a list of the dependencies currently. So as you see, our pip3 freeze returned like has our new Flask dependencies installed. Oh, it's like cut off. Okay. So basically what we can do is we can update our requirements.txt. So we can just first delete it. And then we can do pip3 freeze because we know that the output of this is what we want. And we can say, basically write the output of this command into a requirements. Unfortunate. Oh, okay. Gotta copy my n again. Okay, pip3 freeze, and then we want to write this to our requirements.txt. And then if we read our requirements.txt file again, we have, you can see it now has our 2 new Flask modules. All right, so now we can try starting our Python server by just doing python3 app.py. Okay, so basically, if you look at this output, you can see like SQL Alchemy has done a bunch of things, and basically these are SQL queries that SQL Alchemy actually runs themselves. So if we go to Postman, and we try to get all of our tasks, you'll see that it's this empty list. And then if we go back to SQL Alchemy, you'll actually see that they did their own kind of select query right here. So basically select pretty much all from task. So that's pretty nice because SQL Alchemy will generate these SQL queries for us and we don't have to write any of this ourselves. Does anyone have any questions so far? All right, cool. So let's go back. So how do we create a task now? So we can try to reuse our code from last time. So same thing, we have our post body, but this time instead of making a task dictionary, we want to create a new task object. So we can do task equals and then call our task class instructor. And basically supply the description. So we can say description. Gotta find the n. Where's an n? Oh, here it is. All right. Description is equal to post body. And then we can also use this get syntax. So this get method works for any dictionary. So we can say find the value where the key is description. And then if it can't find it, it will result to none. But as you remember, if we go back to our constructor here, if it's none, it will default to the empty string. So that's why we don't have to supply a default value here. And then we can do the same thing for the done field. Equals boolean post done. And then this bool is just to make sure that it will try to cast something into a boolean. So if they submit like the string false, this will change it into a boolean, which is the type we want. Oh, dot get, yes. And then basically to save our task object to the DB, we can do db.session.add, and we can add our task. And then like last time, we do the session and we do this commit, basically to save it to the database. And then lastly, instead of returning the task object itself, we want to return the dictionary version of it, so we can just do task.serialize. And now we should be able to create our own task. So now if we go to Postman and we try to create a task, so say I wanted to create a task where the description was like studying for prelim. When I send this, we should see that this successfully created a new task. And then if we look at the terminal output, you'll actually see the SQL commands here. So basically insert into task, and then you see that they use kind of the same question mark notation. And And then basically, yeah, setting for prelim and 0, which they represent as like false. Yeah, does anyone have any questions so far? All right, all right, so now how do we get tasks? So say we wanted to query a task by ID, how do we find that? So basically to find it, we can do task equals, and then again, we reference our task class. We do .query to say we're looking for something, and then we can use this filter by, which basically we can give it a condition and be like, only return me tasks that meet this condition. So we can say, make sure that the task ID is equal to this task ID that was supplied in the URL. So filter by will return us a list of tasks that meet this condition, but we know that only at most one task will have this ID, so we can just do this dot first. And then, so if the task exists, we can return the serialized version of this task, like this. Yeah.
Why do you do that first again?
Basically to get the first element. So like task.query, like if you do like the filter by, it will return multiple tasks that meet this condition. So like ID equals task.id, because you can do like other queries too, like or give me like all the tasks where done is equal to like false, right? So then that these all give us multiple tasks back. But since we know that only one task can have this single ID because it's unique, we can do dot first to get the first task in this like group of tasks. Yeah. All right, so now we can go back. So previously we created this task with ID 1, and now we can get this task by just adding this 1. And you should see that this succeeded. And then if we go back to the terminal, you can see that we have this SQL query. So basically select all these fields from task where the ID is equal to this. And here we did where the task is equal to 1. Yeah, so it's pretty nice. All the SQL queries are handled for us, so we don't have to worry about that anymore. All right, does anyone have any questions so far about these 3 functions that we went over? All right, now let's do update task. So pretty similarly, so first we can delete this. Same thing with this. All right. So first we want to make sure that the task actually exists, so we can do task equals, yeah, so we can actually copy this first line here because we're basically querying for a task with our specified ID. So if the task isn't none, we're just going to copy this in here. So if the task exists, we want to update the fields. So we can basically just do access like the properties of this task object. So we can just do task.description is equal to postBody.get description. But what happens if they don't supply us like a description field? What should we update this value to? So generally, if they don't specify like a new value for description, we should just keep it the same as before. So we can just reference the old description value. And then same thing for done. We can do task.done is equal to, we can wrap this in a Boolean to make sure postBody.get. And then we can do done, and then if not, keep it the same value as it was before. And then to save this, we can just do db session.commit since this object is already in the database. And then we want to return the serialized version of this. All right, yeah.
What's like your preference for if task is not none, like returning early, or like if the task is none? or like doing it the opposite way? Like, is there a reason why you return false outside and like do the checker if it's none like inside?
No, it doesn't matter.
Okay.
Yeah, you can do it either way. Yeah, because yeah. So now if we wanted to update our task, we can go back and do a post request to our task 1 because we want to update the post with ID 1, and then in our description we can do like do project, and then we can send this. And as you can see, we only send the description, so false stayed the same. But say right now, if I wanted to submit done and say this is true without supplying any description whatsoever, we can see that the description stays the same and only done updates. And then if we look back at our terminal, you can see that they have this update task. Yeah, basically kind of like the same question mark syntax that we used earlier. All right, does anyone have any questions about this so far?
Oh, I also have a comment. Wait, if you want to go back to the terminal output.
Yes.
Yeah, so this is like an example of where ORMs kind of like don't provide all the functionality. So if we look at this part, 1 second, let me just highlight it. Oh, okay. Whoa, wait, can you re-highlight?
It goes over this part?
Yeah. Okay, so if we look at the limit and the offset, basically when we query for the first element, it's saying limit is 1 and then offset by 0. So like get the first element and then don't offset by anything like when you execute the query. But let's say you wanted to access like the second element, right? But SQL Alchemy actually doesn't provide a function to do this. They only provide the first function. But then in SQL, like we would be able to write, oh, where task ID equals this, limit 1 and then offset 1, but then we don't get that functionality through an ORM, right? So just like, I don't know, something to think about, I guess.
All right, so we're gonna do delete task now. So let's unhighlight this. All right, so basically we're gonna start with the same thing. So first we wanna make sure that the task we delete actually exists, so we can just replace that with this. And then we can say if task is not none, then basically we do db.session and then .delete, and then we give it the task that we want to delete and then tell it to save. And then we want to return the task that we deleted. So earlier we saved it to this task variable, so we can just do .serialize. All right, so now we can go to Postman and say I wanted to delete, let's make a new task. So let's say, yeah, studying for prelim. So now we want to delete this task with ID 2. We can make a new post or a new delete request to localhost task ID 2 and then send this. And then success was true. So we can check our terminal output, and here it is. So it does the delete from task and with ID 2. So it looks like it worked. We can also verify by getting all of our tasks again, and we only see our task with ID 1. Yeah. So now, so basically that was with one model, right? But how do we do some? Oh yeah.
So the ID request is a primary key. So why we need dot first?
What did you say?
Yes, a task dot first. Like the ID is the primary key, right?
Yes.
So why we need dot first? It should be only one task ID equals ID.
Yeah. So by default, filter by always returns like like the return value is like multiple tasks. So because you can filter by other things, like you can say like when done is equal to false, and that can return you multiple tasks. But since we know that, like you were saying, that we know that there's only one task with that ID, we can do this dot first to be like, just give me the first element, because we know that if it exists, it will be the only one. Yeah.
So it returned multiple tasks if
No, it'd be like a list of tasks with one element. Yeah. Similar to how when we did in the last demo, we did like select star from task where ID is equal to whatever. We still had to iterate through that cursor, but we already knew that it was going to be the first one. Yeah. Yeah. Any other questions? All right. So yeah, so this was with only one model, but how do we do relationships in SQL Alchemy? So like for your assignments, like how do you map like comments to posts with SQL Alchemy? So to demonstrate that, we're gonna add something called like subtasks. So a task will have multiple subtasks. So for example, like if I was doing like if my task was like study for my prelim, some subtask would be like read chapter 1, read chapter 2. Basically, very similar to like the relationship between post and comments. So this will definitely help you out for your assignment. So basically, first, how we can start is subtask is going to be very similar to task. So we can just copy and paste this class, and then we can edit the name. So we'll change this to subtask. We're going to also change the table name to subtask. It's still going to have a description and a done field. But now we know that a subtask belongs to some type of task. So to keep track of the task that it belongs to, we can add a task ID field. And we can do db.column. And then it's an integer. And then we can tell SQL Alchemy it's a foreign key by just doing db.foreign key. And then basically saying this references the task table and then the ID field of the task. And then we don't want this to be null, so we can do nullable is equal to false. And then in our constructor, we also want the task ID to be passed in, so we can assign that here, doing quargs.get task ID. We don't want to set a default ID for this one because we're going to assume that they have to give us a task ID. And then the serialization will stay the same since these are the fields that it has. All right. So now how do we tell, let me keep this on this for a little bit. So how do we tell task that it has multiple subtasks? Similarly, like how like a post has multiple comments. So what we can do is for task, we can basically give task a list of subtasks that it has. So we can say subtask is equal to db, and then to specify the relationship between task and subtask, we can say db.relationship, and then say that it has a relationship with the subtask class. So this is capital because it refers to this class itself, not the table. Yeah, that's just kind of how SQL Alchemy expects this argument to be. And then we can do this cascade option and say delete. So basically what this means is if we delete a task, also delete all of its subtasks, right? Because for the assignments, if you have a post and it has multiple comments, if you delete that post, you have to delete all those comments also because those comments, like the task that it used to belong to doesn't exist anymore. So generally, we use this cascade, which means if task gets deleted, delete all of its subtasks. So similarly, like you would do something with posts. So like if a post gets deleted, delete all of its comments also.
Oh yeah, and I have some things to add. So it's like really important to keep the syntax in mind. So here it's like one task has multiple subtasks, and like the thing that has like the one-to-many relationship, it refers to the Python class, so subtask. But then if you scroll down, like this is task.id. So this is like really bad syntax actually. Like this is super confusing, but like you guys should definitely watch out for it when you're doing the assignment. Like the first one, it refers to that refers to the class name, and then the second one refers to the table name dot the field. And then something else to note is like the cascade behavior for one-to-many relationships. It's default to delete, but there are some other options. Like for example, if you delete a task, like maybe you could just set that key to null, right? And then there's like a cascade equals like set null or something. There's a bunch of these different options, but the most common one is delete. Yeah.
Yeah. All right. So now we're gonna go back to our app.py, and then we need to import subtask in here. So now say we wanted a route to create a subtask. So we can let's just copy this so we don't have to type everything out by hand again. And then this time, so the route's going to be task, the task ID, and then subtask. So basically get all the subtask for the task with this ID. And this is going to be a post request since we want to create a new subtask. So we can name this function create subtask. And then we can keep this because first we want to make sure that the subtask the task that we're creating a subtask for exists. So if this task exists, we want to first we want to get the post body, and we can do just the classic JSON.loads request.data. And now we can create our subtask. So similarly to how we created a task before, we basically just call the constructor of our subtask class and then give it the parameters that the client gave us. So description, post body, .get, description, done, bool, and then this time we want to do task ID is equal to, so we can either supply this argument, so task ID, the one in the URL, or you can also access the ID of this task object. So I can just do task.id. Both of these values will be the same since this task has this ID. So yeah. And then basically, so now we want to add this to this task list of subtasks. So what we can do is we can just do task.subtask.append, and we want to add this subtask. And then we want to save this subtask to the DB, so we can do db.session.add, and then subtask, and then save everything with commit. And then rather than returning our task serialized, we want to return our subtask that we just created serialized. Yeah. All right. So let me restart my server. So now if we go to Postman, so I have my get task. So say I wanted to create a subtask for my due project task, I can go to post localhost 5000 task, the ID that I want to create a subtask for, so 1, and then subtask, and this would be a post request, and the description could be something like read chapter 1. So if I created that, oh, let's see, no column ID subtask dot. Let me go back. Did I forget something in app.py?
What was the error?
Column doesn't exist, task.id.
Yeah. This run create all. Okay. There's a mystery.
Let's see. All right, so we can debug this by going to our SQLite. So we can just use SQLite and we can look at our todo.db. And then to check the tables, we can do .tables. And we seem to have subtask here. If we want to look at the schema, we can do .schema subtask. And it looks like a task, there's no task ID in here. So let's go back and look at our db.py file. Yeah.
Pick up the comma after supports that get
Done where? This is
You want to scroll up?
yeah.
Subtasks equals. No, not sure. Looks like it should work. TV,
All right. Let me try.
I'm starting the server.
Yeah. Let me delete this.
Did you save tb.py?
Did I save? Yeah.
Okay.
Let me delete this and try restarting it. Sometimes the auto restart does not work. Oh, okay. So now it's there for some reason. So if we look at here, we can see that now it includes a task ID field. I don't know why that wasn't there in the beginning. So yeah, if you ever get weird errors like that, try restarting your server and like deleting your database because yeah. Okay, so let's try creating a new task or a new subtask. Oh wait, I need to create my task in the beginning again. So let me just make that real quick. Okay. And then we'll post our subtask. Oh, and there it is. So now I have a new subtask. Notice how the ID is 1 because subtask and task have separate IDs, so those start from the beginning. And then, yeah, with our description, and then automatically done is false. All right, so our last one. So how do we get all the subtask of a task? So basically we can, let's just copy our get task method because that's very similar. So the URL for this will be task, the task ID, and then subtask. And then we want to get subtask. So it's very similar to how we got our task. So first we want to make sure that the task that we're getting the subtask for exists. If task is not none, then we can do subtask. And basically how we can access it is we can basically just do task.subtask. But task.subtask is a list of subtask objects. So like before, this isn't readable to the client because it's like a Python object that's saved in memory. So we need to return the dictionary representation of this. So we can do the same list syntax that we did before. So we can say subtask.serialize for subtask in task.subtask, and then basically we can just return this. All right, so now if we go back to Postman, so I created this subtask. Say I wanted to create another one for task 1, so like read chapter 2. I can submit that, and let's do read chapter 3. Oh, I accidentally deleted. There we go. All right. So now if I want to get all the subtasks for task 1, I should see like read chapter 1, 2, and 3. So if I do the get request to the same URL, we'll see a list of the subtasks that I just created. All right, so does anyone have any questions about anything we went over today in demo?
All right, I have a question for you guys. So like here we can see like the adding to session and committing are separated, and that wasn't something that was present in our SQL code. Does anyone have any ideas why? Like, why is this useful? Why can't we just add and then it just like adds it in the database? Like, what's the point of having it split? Does anyone have any ideas? Okay, so the reason is actually like, if you think about, so let's say a client makes a request to a server and they want to create like 5 subtasks, right? Like it's a new route that we implemented. If we created all those subtasks individually, usually you have your database hosted somewhere else, like maybe even in a different region, right? and the latency between your server and the database is really high. So it's actually really important to package as much into the queries as possible. And so like in that case, if you wanted to create 5 subtasks, you'd add it to the session and then you'd commit all of those changes at once to avoid making that really expensive call. And it's something to actually keep in mind, like especially in future projects, you never want to be committing to the database inside of a for loop because that can take a really long time, especially in later assignments where we actually deploy stuff. Yeah, so it's just something to keep an eye out for.
Yeah, yeah. So we're done for the day. If you have any questions, you can come up after. But yeah, yep.
Can you post the code?
No, because last semester everyone would just copy and paste it into the assignment because as you see, it's like very similar. So like people would just copy and paste it and change like the URLs from like posts from like task to post and like subtask to comments and then just submit that and like not change anything else. So we want you guys to at least type it out like once so you kind of at least understand what's kind of going on. But yeah, but we'll post a video.
Nice. So I installed the requirements using pip.